The question is, where does the carbon dioxide go? The idea is that, as I said, it sinks to the bottom of the ocean, where it may stay or it may quickly leak out into the atmosphere again. And it's been observed, actually, on some of the experiments, the small-scale experiments, that actually water does return to the natural condition rather quickly. So frequent seedings will be required in order to keep it going. Even if it works, it could only offset really about a third of the global carbon dioxide emissions, and there may be side effects. The growth of plankton on a massive scale would alter the ecology with unknown consequences, and the decay of organic matter could remove oxygen from the surface and kill marine life, and even generate methane, which is actually even worse than carbon dioxide, the worst greenhouse gas. So there may be consequences that make it not such a good idea. There have been a number of experiments, as I say, over a period of time. Even so, it's not quite clear what the repercussions of some of those experiments are. But even so, two San Francisco-based companies are planning to sell carbon offset credits in the form of iron scattered in the Pacific. So some of these processes may already be underway to some extent. Iron seeding might fall under the Environmental Protection Agency's 1988 Ocean Dumping Act, but that only applies to boats registered as US, and of course you can get around that by registering your boat in other countries. Another idea is for a sunscreen, the so-called sunscreen proposal, which is also known as the Pinatubo effect, named after the volcanic eruption. This involves the controlled emission of dust particles to reflect solar radiation. It creates the human equivalent of one of the Mount Pinatubo eruptions a year, which is enough, the proposers suggest, to counter carbon dioxide warming, or warming effects due to carbon dioxide. This has been investigated by injecting massive amounts of sulfur dioxide into the stratosphere from commercial 747 flights. Again, it's not quite clear what all the results of those things has been, but some of the suggestions are that it might cost around $50 billion, that's in 1984 dollars. So it's not cheap, but it also could damage the ozone layer. There's suggestions that the ozone depletion may be enhanced by this, or at least the mending of the ozone hole would not be as rapid as it might be otherwise. The idea has already been suggested to President Putin in 2005 that Russia start pumping enough sulfur into the atmosphere to produce around 2 degrees of cooling, but that idea hasn't been taken up as yet. Another idea is for increasing cloud reflectivity, again to reflect the sun's solar heating. And John Latham and Stephen Salter have designed a fleet of these wind-powered ocean yachts to pump micro droplets of seawater into clouds, and they would then act as condensation nuclei, which makes them brighter and more reflective to solar energy. The idea is that you could boost the albedo, that is the reflectiveness of the upper atmosphere, by about 3% of low-level marine stratocumulus clouds. These are clouds that occur over the oceans, and they cover at the moment about a third of the oceanic surface. That could reflect enough sunlight to curb global warming. That's the idea anyway. These vessels would be unmanned. They would be powered by a particular a new type of kind of engine, a Fleckner rotor, which is a spinning vertical cylinder, which could also house the spraying system as well. The power could be generated by turbines, which are dragged along behind the vessel, so there's no kind of power generation necessary other than that, theoretically anyway. It's not clear how many of these vessels would be needed to produce this particular amount seeding, but the estimates are between 5 and 30,000, which is obviously quite a lot. Okay. Other ideas, filtering carbon dioxide from the air. The idea here is to use extractors, like been likened to sort of flypaper, where you put these great carbon dioxide filters into the air, and then the atmosphere passing through them, it will keep the carbon dioxide, behind, so removing it from the atmosphere. Some tests, some successful demonstrations have been claimed, one in April 2007 in particular, and these kind of wind scrubbers, as they're called, could be conveniently placed wherever is necessary. They don't necessarily have to be in any particular place. They may be positioned in a place where, for example, a lot of carbon dioxide is generated, power stations, that kind of thing. Again, the proposers calculate that the wind scrubber designed to retain 25 tonnes of carbon dioxide per year would be about the size of a large plasma screen television. And on the other hand, an industrial size scrubber could be something like 200 feet high and 165 feet wide, and maybe track something like 90,000 tonnes a year. Again, these are estimates put together by the proposers. I haven't seen the calculations that made them arrive at those numbers. Very often engineers do kind of get their numbers wrong in the first instance when they're just looking at ideas rather than practical or the actual building of something through experience. These things might not be so easy to separate carbon dioxide from. What happens is there are binding chemicals that are used here, which are pumped through the system, and then the carbon dioxide kind of sticks to that. And then the carbon dioxide has to be removed from those binding chemicals later on and stored, or something done with it in some other way. However, it's not, I don't think it's clearly understood how that process works. It might not be quite so easy to separate the carbon dioxide from the binding chemicals as is being proposed, and the process could require much too much energy to do that than is being assumed. To capture, another calculation has suggested that to capture all the carbon dioxide produced by humans would require wind scrubbers to fill an area the size of Arizona. To give you some idea. The storing of carbon dioxide underground is something that's probably been around for a while now, and is something that's actually occurring at the moment, mainly by oil companies who, what they do is they pump thousands of tons of pressurized and liquefied carbon dioxide underground to drive oil from the porous rock, to suck the last bits of oil out, but also at the same time to trap the carbon dioxide underground. And millions of tons of carbon dioxide have already been sequestered in this way. And there are lots of other projects undergo at the moment. One of the problems here, of course, is that because it's liquefied carbon dioxide under pressure, if somehow or other those chambers are punctured, there could be some difficulty arising from that, especially if carbon dioxide leaks out, especially if it leaks out into inhabited areas where it may cause all kinds of difficulties, maybe even deaths. Some estimates are that underground reservoirs and saline aquifers could store as much as 200,000 gigatons of carbon dioxide. But again, those are estimates.